Hello everyone. In this part we will learn our second chapter, array as data structure. We know that array is a user defined data structure. In this chapter we will learn the different points. From this we will cover these points in our video. Editing of array, operations, array applications, searching. In searching we will learn sequential search, variations in a sequential search, sentence search, probability search, ordered list search. Let's see one by one. Array. Array is actually abstract data type. Why array is additive? Because it holds a collection of elements accessible by an index. Actually, additives are a way of classifying data structures based on how they are used and behaviors they provide. The array additive have one property. Okay, which is this property? They store and retrieve elements using an index. We are using the index number for storing and retrieving the element. The array additive is usually implemented by an array data structure. Okay, we can perform the operations on array like a traversal of array, searching inside array. What are the applications of array? Mainly, we are using the array for the searching and sorting. These are the important applications of array. We are using the array in CPU scheduling algorithm, and in many applications we are using the array. But these are the two important applications of array. Searching. It is a technique of finding an element in a given list of elements. Here are the different methods for the searching. Sequential searching and binary searching. Sequential means here we can say it is a linear searching. Here we are searching the each and every element. Okay, one by one we are checking. In binary, in case of binary, we are dividing the whole array, and then we are start searching depending on the key and the condition. Okay, inside the sequential searching, there are the three types: sentinel search, probability search, and ordered list search. Sequential searching means what actually? Here we are examining all the elements starting from the first element. The process of searching terminates when the list is exhausted, okay, or the list is end, or a comparison result in a success. Then we will stop. Okay, the sequential search is used whenever the list is not ordered. Okay, if the list is ordered, then we will use the binary search. We will also use this sequential search, sequential ordered search. Okay, the sequential search is used whenever the list is not ordered. Generally, you use this technique only for small lists or the list that are the not searched often. Okay, see here is one example. Here is the array. Okay, in array the elements are 10, 5, 20, 45, 13 and 15. Okay, suppose a query search the element 20. Okay, let's try to search the element here. Okay, first compare this 20 with the first element. Okay, this 10 and 20 is not equal, so again search. Okay, again the second comparison is here. Okay, compare this 5 and 20. This 5 not equals to 20. Okay, then search with the next element. Okay, here is 20. 20 equals to 20. Okay, successfully we found this element 20 at the third location. So return the location third and the true, because this is found at in this array. Suppose same example, we are using the next example. Search the element 16 inside this string. Okay, see, first element is 10, then 5, then 20, then 45. Compare with this first element. This 10 equals to 16? No. Then go to next one. Okay, search here. 10, 16 equals to 5? No. Then again go to the next step. Okay, then 20 equals to 16? No. Then go to the next. This 45 equals to 16? No. Here is an end of array. So stop here, and this element is not found inside our array. So it will returns the false. Next is, let's see the C function for sequential search. When we are searching, then this is our array, this is our key, and this n is number of element inside the array. See, here is array, this is our key element, and number of element 1, 2, 3, 4. Okay, so n is your 4. While I less than n, okay, till the less than n, less than, not less than equals to less than n, if a of I equals to key, if you found the element a of I, if you found the element this key inside your array, then return I, means the return the index number, return the location. If not, then increment the I, then check again for this till the end of array or the successful operation. Otherwise, search means what? Here we are adding the one extra value at the end of array. This additional entry at the end of this list is called as a sentinel. Okay. Which value we are adding? We are adding the key element. Okay. Sentinel value is the one who presents guarantees the termination of a loop that processes structured or sequential data. Okay. So let's see. Here is a pseudocode for this algorithm. Sentinel search. Here we are providing the list or last and then target and this location. Okay, list. List contain at least one element. Last is index to the last element in the list. Target is contains the data to be located, and location is address of an index in calling algorithm. See here, set list of last plus one to target. Okay, target means what? Contains the data to be located. We are assigning this target to the list of last plus one, means we are adding the one value at the end of our array, end of our list. Then set looker to I. We are setting the one value to the 0. Then loop target not equals to list of looker. Okay, till which we are finding, okay, target not equals to list of looker. Okay, till the end, till the key we are finding, increment the looker. Okay, till this increment the looker till the target, then end loop. If looker less than equals to the last, then set found to true. If found, then set found to true and set location to looker. Else set found to false and set location to last element. Then end if. End if. Here is a end if. And then see, here is a if is starting from here. One if is from this to this. Okay, and one if is from the starting. So end if, then return found. Okay, then after this return found and then end probability search. Here is a code for this boolean. Okay, it will return you either true or either false. So sentinel search, here is your key int I. You can assign this key to the roll number. Okay, key to the roll number of n. If for I equals to 0, roll number of I not equals to key, till this key we are finding and incrementing the counter. Okay, if I less than n, then it returns true, otherwise returns the false. Sentinel search. Okay, in this algorithm we are adding one extra value at the end of our list. Here we are adding value at the end of list. And this additional entry at the end of list is known as a sentinel value. Okay, a sentinel value is the one who presents guarantees the termination of a loop that process structure. Okay, we are doing the algorithm and either target is found or last element is compared, we will stop. Let's see the pseudocode for this. Here is your sentinel search list. List must contain the elements last, index of the last element. Target contains the data to be located, and this is location, address of index in calling algorithm. See here, we are adding the last element, the target element at the end of list, means last plus 1. Last is our index to the last element in the list, and here last plus 1 means we are adding this target at the end of list. Set looper to 0. Okay, then means initial value is 0. Then loop target not equals the list of looker. Okay, कब तक फाइंड करने वाले हैं हम? जब तक ये हमारा टारगेट नहीं मिलता तब तक इंक्रीमेंट द काउंटर. Increment this looker. Initially 0, here increment this looker, then end loop. If looker less than equals to last, अगर पहले ही मिलता है हमें end position से, so set found to true and set the location to looker, means set this address. Else it returns the false and set location to last, and then end if here and return found. Okay, and then end probability search. Let's see the coding for this. When we are using this, here we are returning either true or false. So it will return the boolean value. So boolean sentinel search here is a key. We can use in this way also. We can use this also and this also. Okay, here key is equals to roll number of n. Okay, means the last location, because we are using this I equals to 0 to n minus 1, less than n. But here we are setting this key at the end of list. And till this roll number of I not equals to key, then find till this and increment the counter. And here if found returns true, if not returns false. It is just an example. Next is a probability search. Probability search means what? Here, the most probable search elements at the beginning of the array and the least probable at the end. Okay, where we are using this, it is especially useful when relatively few elements are the targets for most of the searches. So let's see the pseudocode for this. See, here is the same like a previous pseudocode: list, last, target, and location. Okay, must contain at least one element. Last is index to the last elements. Target is a contains a data to be located, and location is address of index in Poly algorithm. See, find target in a list. If target in a list is present, then the set found to true. Set location to index of the element containing the target. Okay, set the location. Okay, then if target after the first element, at that time we need to move the element containing the target up one location. Okay, move this element, because our definition of probability search is most probable search element at the beginning. So we are moving this up. Then in if here, else set found to false. Otherwise return found and end probability search. Our last one type is ordered list search. When list is ordered, at that time we are using the binary search most probably. But we can use this linear search for the ordered list. Okay. If list is a small, we are using this ordered list search. Okay. Here, it is not necessary to search to the end of the list to determine that target is within a list or not. Okay, we can stop when the target becomes less than or equals to the current element. Let's see the example. Actually, we are using this for the linked list. Ordered list, here list, last, target and location. See, if target less than the last element in the list, if this target, this is your target, is less than the last element in the list, find the first element less than or equals to the target. Okay, first compare first element with the last element of the array, then find the first element less than or equals to target, and then set location to index of element. Else, otherwise set location to the last. Okay, and then end if target in a list set found to true, otherwise returns the false, and then end if and return found. In this way we can perform this different searching algorithm on data structure array. Thank you.